Hello, I am Maninde Surya. I am software engineer from WSO2. Here I am going to discuss about the HTTP log monitoring with WSO2 BAM. Uh, in HTTP logs, we can get some information about the web requests such as HTTP method, URI and status code, and also we can get the request metadata information such as message size, host or IP address of the request, and from the host and IP address we can get the geolocation with the support of another service, and also we can get the date and time of the message request. Using HTTP logs we can get many information about the usage of a particular service or particular resource that is available in a REST API. So, and how the users are using it, whether it is overutilized, underutilized, or how can we manage to improve our business depending on the usage of a particular resource. So HTTP logs are very important to be analyzed. So in WSO2 BAM, we already have an existing HTTP log sample that can be used to analyze HTTP log samples and analyze data and extract information that are useful for getting insight into the requirements of a C-level employee. So in the existing example, these are the things we do. First, there's a sample HTTP log file that contains a set of entries, that means set of lines that are corresponding to HTTP requests, and with that file in the HTTP log sample, when we execute the log sample with an AND command, this log file is read and each event is sent to the BAM as a separate event. So for each request, the messages are sent to the BAM as separate events and they are stored in the Cassandra database. So after the data is into the Cassandra database, we run the Hive script, which is automatically scheduled when the toolbox is deployed. When the Hive script is run, it will get the information in the received HTTP log data from the Cassandra, and it creates another column family which stores which extracts the information from the received data and put it into a descriptive way. For example, in the first column family where the data was received, there are only a set of strings. From the Hive script, we split it into spaces and extract the data such as host, IP address, time, message size, and so on, and we put them into separate fields, so they can be used thereafter. So that is what is happening in the Hive script. And then there's and also other than extracting data, we resolve them into a set of geolocations. That means in the HTTP log sample, we only have IP addresses as the instead of host names. So we resolve IP addresses to geolocations and store them into the RDBMS. That happens after the first step. That means first step is processing data from the input column family and store the data into the second column family after splitting data and extracting information. The second step is resolving IP addresses and summarize data and store them into the relational database. So in the relational database there are very several number of data, so the data fields. That means it cannot be a big data. Big data in the relational database. So we summarize those data, and that means categorized by the region, country, or some other thing. In our sample, we use the country code as the summarizing grouping field. So after summarizing, we put them into the relational database. Here we use the GeoIP open source implementation to resolve IP addresses to country names, and we have a dashboard which consists of set of gadgets, which are basically tables and bar charts that can show the number of requests came for each country, and their variation is displayed in the bar charts. So that's all what we already have in the HTTP log sample. In this demo, we are going to extend the existing toolbox. Here we are using a real HTTP log sample, which is available in the given URL http itaellbl gov html contrib epa http html. It's a 24-hour real log sample which contains a lot of host addresses and IP addresses, and instead of resolving IP addresses into geolocations, we are doing some other analytic stuff in this demonstration. So there are 3 scenarios we are going to cover in this demonstration. They are as follows. First, we are analyzing the request count variation for each host. That means with this analytic, what we expect is we are finding who are the hosts that are most interested in our service. That means what are the hosts that are most visiting into our site, or accessing our web resource or something. So we can, using the bar chart, you can easily identify the most accessing client to our web service or REST API or someone. So that will help us to identify the most important customers in the business perspective, or some other things that are critical for propaganda campaign or something else. In the second analytics, we are analyzing the request count variation for each hour. That means this parameter is mostly used for predicting the load of the server within 24 hours. We can estimate what about the load in each hour, so we can predict the resource consumption in our system. If we are using a private pass or something, or public pass something, we can estimate what will be the usage of the pass and what is the time the users are coming to the site very frequently. So if we are using some modification to our site, what is the time we should use it. So if we are advertising something, we can analyze what are the prices should be given for each hour, and so on. So that is very useful in business perspective and also in deployment perspective. The third analytic is we are going to analyze request message size variation. That means we are analyzing what are the number of messages that are received for each message size group. Actually, we are not visualizing the message number of messages per each message size because there are a lot of message sizes, so we group them into some groups. In this example, we are using 100 as the group size. So for example, from 0 to if the character length is 0 to 100, it should be in the first in the 0th x value. If it is 100 to 200, it should be in the second x equals 2 value. Similarly, we can analyze how many messages were received for each message size difference. This parameter is important if we are if we are going to use some solution such as an ESB. What is the memory it would take? That means if the size of messages are very high, then we should dedicate some more resources, for example, more memory for the ESB and so on. So we should in order to determine the message sizes, in other words the message load, we can use the third analytic. Okay. In the final dashboard, this is how we get the results. The first dashboard, in the first gadget, it shows the request number of requests from each host. That means you can see some hosts have very higher number of requests. It is sorted by the number of requests, and you can see the decrease of request counts for each host. And in the middle gadget, you can see the hourly requests. What are the hours that requests came mostly into the server? You can see there the 14th hour, that means 2 o'clock PM we get the most number of requests, and in the 3 and 6 of hours you get the minimum number of requests. So we can get some idea about how the users are using this service with this bar chart. The third one shows the request size variation. You can see the most messages are with the least size. That means most messages were equipped with very small message sizes. You can use a different scaling level for get more for fine granular visualization if you want. Here I have used the group size as 100, and if you want you can get only the first 1000 or 10,000 sizes, so the empty part of the graph will be not there. So that means the right part of the graph, there are no messages in the represented in the bar chart, so you will not get them if you can produce the number. Okay, now I am going to extract a new fresh BAM pack which is in BAM 240 version, and I will I have an already extracted BAM pack, and I will show you how to start it, and then I will install my prepared toolbox, which has some modifications from the original HTTP dlog sample toolbox, and I will send some events to this our new BAM toolbox installed BAM server, and I will create some gadgets in front of you, and I will show you the results displayed in the gadgets. Okay, now I am going to go into the BAM directory. Okay, now I have started the BAM. This is a new fresh BAM pack. Now you can see the server is starting. Okay. Okay, now I will open the server in a new window. Well, now I will log into the BAM server with username admin and password admin. And sign by pressing on the sign in button. Okay, now if you go to the BAM toolbox menu item, which will show all the existing BAM toolboxes. Now there is only one BAM toolbox, which is message tracing toolbox, packed with BAM 240. It's a default toolbox, so I haven't installed any other toolbox to the BAM. Now I am going to manually install my new toolbox. First, let me show you the content of the new toolbox. Okay, this is my new toolbox, which has the same name of the old HTTPD log name, toolbox name, and you can see the dashboard directory is removed because I am going to create my own gadgets for the example. And in the analytics folder you can see the same name, but the content is different. Okay, I will explain it after I have installed the toolbox. Now this is the location of the new toolbox. Now I am going to add the new toolbox into my freshly extracted BAM. I will select a custom toolbox and toolbox from the file system, because these are the existing packed in toolboxes which can be installed. This is how I should install a new toolbox. Then now I should show the file location. You can see the demo. Now it is the HTTPD logs. Okay. Now I should click the install button to install the toolbox. Now you can see it is installing. This is the backend console. You can see the toolbox is deploying. Initialize the cluster English definition, and the stream definition was created, and the task was scheduled. That means the Hive script was created, and the toolbox was successfully deployed. Okay, now you can see the toolbox was installed. Now if I go to the analytics list, now you can see the Hive script that was installed from the toolbox. Now you can see the toolbox has installed, and the scheduled Hive script is running. To ease my demo, I will unschedule my toolbox, unschedule my Hive script, because otherwise it will be difficult to show the console when the Hive script is continuously going on. So I will unschedule the toolbox. Okay, I have unscheduled it, but the running Hive script is still running until it gets finished. Okay. You can see it takes some time to run the toolbox, but this time delay is not that will be a problem, because it's naturally batch process, so it may take some overhead time to submit jobs, so it's natural to take some time, but this you should not expect the linearly increase of this time with the amount of data. So because the most of the time that took for this MapReduce job running was for the overhead. Okay, now you can see the job has finished. Okay, to ease my demo and show you the RDBMS tables that were created, I will use this H2 client, which is the H2 is RDBMS. So the default fact RDBMS type in BAM2 is H2. So in order to explore the H2 database, I am using this tool. I am starting the H2 in this demo. Okay, I have started the H2 client. I have set the location JDBC URL, which is same as the BAM database, BAM data source, BAM stats DB auto server true, and username is WSO2 carbon, and the password is also WSO2 carbon. Then I will connect to the database. You can see there are three tables were created, because the Hive script has, after the Hive script has run, the three database tables have been created. If you explore the tables, you can see there are no data, because I haven't sent any data until now. I will show you first the content of the Hive script, and I will send the data with the new sample. You can see the every table is empty. Okay. Now I will show you the content of the Hive script. Let me go to the Hive edit view. Let's look it in full screen mode. Okay, now you can see the earlier httpd logs create table if not exist table http log table. This is same as the earlier table, Hive table, but this table has changed. This is the create external table if not exist processed logs. Some parameters have removed, some parameters are added. For example, but log ID, remote IP, and those things are there, but I can show you the new things. which are request tower, HTTP code length. Some of them are there, and I have added some of them. And for the new format of the log file, I have changed this insert override process logs script. That means I have separated the log line with different number number of spaces. Sometimes I have splitted it with the first one, and so on. Okay, if you look into this and carefully, you will understand how I have splitted the log line to extract the required fields. The next 3 tables are newly added tables for this demonstration. This is the host summary. Host summary means it has the request count came for each host. Host name, host can be an IP or the host name of the server that has sent the request. You can see the SQL query that I have used. For more details, you can refer our documentation available in the WSO2 site for learning Hive scripts. And for learning furthermore, you can refer the Apache Hive documentation, and you can examine our other existing toolbox Hive scripts and so on. Okay, this is the host summary table, and this is the request hour summary. That means this represents the number of requests came for each hour of the day. If it was 2 days, 3 days, or 7 days, whatever the number of days, there must be only 24 elements in x-axis. Those are for the 24 hours. For each hour, how many requests has come? It is stored in this Hive table, which is an RDBMS table, request hour summary table. This is the request size summary, which represents the size group and the request count received for each size group. For example, how many requests has come with the size 100 to 200? How many requests has come with the group 400 to 500 characters, and so on. 3 of them are H2 tables, as I have shown in that was created in the H2 Explorer. You can see it. Okay, now the third part is insert override in the summary table, our request summary table, and request size summary table. I am not going to explain each and every statement that was mentioned in this Hive script, because you can refer our documentation and Hive documentation and understand the meaning of this Hive scripts. Okay, now I am going to cancel this, and now I am going to send the data with the new sample log file. Okay, now I will go to the I will show you the location. This is the HTTP log sample location I have used to download the log file. Okay, now I will show you the downloaded one. This is the downloaded log file. You can see there are host IP addresses and host names, and you can see the date, time, the HTTP request, status code, and the message size. Okay, now I am going to copy this into the samples HTTPD log resources. Okay, now you can see the original access log file. This has the original content, came with the original HTTPD BAM log sample, which is different from the file now I am going to use. So that's why I have changed the Hive script according to our requirement. Okay, so in order to change this thing, I am going to rename the downloaded file. Sorry, okay, you can see the content. I have renamed the old file with the new downloaded sample. Okay, now I am going to run the sample to set the events back to the BAM server. We'll open a new window and now I am going to run the sample with ant command. When I enter the ant command, it will send the log messages to the BAM server as different events. Now you can see the data is sending. Okay, all the data has gone. There are 47,748 events. All were successfully sent. If you go to the Cassandra Explorer like this, I'm going to the localhost username and password admin and admin. I have set the maximum result count to 100,000 because there are more than 47,000 records. And now I am connected. If you go to the event case where all the created streams are located, you can see the WSO2 sample HTTPD logs where the created column family for the received events. Okay, you can see the 47,748 entries. It means all the events were correctly sent to the Cassandra database. If you explore it, you can see there are 8 fields: the description, the stream name, the nickname of stream name, the stream ID, the timestamp sent, the version of the stream, the client type, and the payload log. This is the most important field that we want. We are going to split this content by space and store in another process logs column family. uh, which can be used to uh, summarize the data and then visualize those data in the dashboard. Okay, if we go back to the event case, you can see the process logs column family was already created as the Hive script was initially run automatically, but there are no data as there were no data in the uh, earlier shown column family, so there were no data to be extracted. Now I am going to run the Hive script, and the data in the earlier column family will get splitted into fields and be stored in this column family. Okay, now this is the analytics UI. Now I am going to execute the Hive script. Now it is executing. Now you can see the MapReduce job is running. I will remove this window. Okay. And now the job is running. So all the data in the received column family will get splitted and stored back into the process logs column family. So when you change the log file format, you only have to change the logic that was in the let me show you. That was in the second Hive query. You only have to change this column family fields and this process logs insert overwriting logic, because this is same for all the, this can be reused for all the log file reading operations. Okay. Okay, now you can see that my MapReduce job has finished running. Okay, it has successfully finished. Now if I go to the Cassandra Explorer as earlier, we should be able to see the content in the process logs column family here. Okay, it has worked correctly, and there are 47,748 entries, which were exactly the same number of events we have sent. If we explore one of them, you can see there are 7 entries. From the Hive script, we could split the log entry content into HTTP code, length, remote IP, request, request date, request hour, and version. So using these few fields, we are going to summarize the data. Actually, it is already summarized in the Hive script, so you will be able to see those data in the H2 database, and if we then we can generate the required dashboard components or gadgets based on the RDBMS data. So using these values, you should be able to see the summarized data in the H2 database. So let me refresh it and let's see what are the data in the database. Okay, now you can see some data. There are 1000 rows or summary. If you there are 24 hours, there are 24 rows, as I have mentioned. There cannot be more, there should be exactly 24 rows for the 24 hours of the day. If you run the request size summary table request right summary database, you can see this data. If you sort by request count, you can see like this. The most messages were with 0 size, and then it size 1. And if you sort it by the size, you can see as follows. Actually these sizes are not exactly the same sizes. These are the size groups. 0 represents the sizes between 0 to 100. 1 represents the 100 to 200 sizes. If you want to clarify how it happened, I will show you in the analytics script. When updating the request size summary, you can see the length was integer divided by 100 and taken as length g, and grouped by length g, and sort by length g in the ascending order. So that means the length is grouped by the size 100 and sort by the length by the group with the ascending order. Okay, now the data they are in the RDBMS. The next step is to generate some gadgets to visualize the data that from the RDBMS. There are two ways to visualize data from BAM. One is creating a custom dashboard, and the other one is creating your own visualization framework, or the easiest way is to use the gadget gen tool. For in this example, in this demonstration, I am going to use the gadget generation tool to generate 3 gadgets to visualize data in the 3 tables that I have created. Okay. Now I am going to generate the gadgets for these 3 tables to reduce the number of errors I face in this demonstration. I have previously set the content that I am going to enter to the UI, so you can read it and the content that I am going to enter. Okay, in order to generate gadgets, you should go to the tools tab, gadget gen tool. For JDBC URL, you can find it here, something like this. I will have to edit it according to my requirement. the driver class name is H2 driver. The username and password should be WSO2 carbon. These are the default values comes with BAM pack. Now you can validate the connection with this button. Yes, it is successfully connected to the database, so that means I can proceed. Let me go to the next wizard item, and I am going to run the SQL statement to generate the gadget. This is the SQL statement that is querying the database as the data source for the gadget. So I have previously typed this query. This is the query. You can preview the results. This may be somewhat different from the actual data in the because I am going to use this data in the bar chart, but not in the table. I have selected the bar graph, and I am going to set the title requests for hosts. And for the y-axis label, I will set the request count, and for the x-axis label, I will select the host. For the y-axis column, it should be the request count, and for the x-axis column, it should be host. So this will show the request count variation with the host, which is sorted by the request count. Okay, now the gadget title should be something like this. Then you should give a file name, gadget file name, which should be stored in the registry. This is the name of resource that will be stored in the registry as an XML, which contains the gadget. So then when you create the generate, it will create the particular file in the registry. This is the location of the registry location and of the file that was created for the gadget. Then I should copy it with Ctrl+C. Then I should go to the dashboard to deploy this artifact in the dashboard. Okay, now I am going to add gadgets. Then I am going to enter the gadget location, which is in the registry. Now I am going to paste the copied gadget XML location. Then I press the add gadget button, and you can see the variation of request count for each host. Because there are large number of hosts, you can't see the host names, so that's why you can see it as a dark line. You can modify the Hive script, and you can filter and group the host names that you want to visualize, and you can use your own custom visualization based on your requirement. Okay, now I have created one gadget. Okay, I am going to close this. Now I am going back and up to the data source location. Now I am going to create the next gadget. This is the Hive script. Sorry, this is the SQL query for the data source. Let's see, you can see the results, maybe somewhat different. Select the bar graph and select hourly requests as the chart title. For the y-axis we select the request count. As the x-axis I will select the hour. I will enter the hour. For the column name it should be request count. For the axis to for the x-axis I should select the hour of day. This preview may be somewhat different from your actual preview, so don't consider this. Then press the next button. For the gadget title, let me include this one, hourly request count. And for the file name I will enter this hourly this is the refresh rate, which is the time duration that the gadget will get refreshed. That means within after 1 minute the gadget will retrieve data back from the database and the gadget will get redeployed again. This will happen continuously because this can reflect the changes in the database when the data gets changed periodically. And let me generate the gadget. This is the gadget location. And go to dashboard. You can see the earlier gadget. I am going to add another gadget. For the gadget location I will enter this gadget location and add gadget. Now you will see the hourly request count variation with each hour. Now you can see that there are only 24 items in the x-axis and how it varies. Okay, let me close this back and create the third gadget. This is the data source query for the third gadget. Request summary. You can see there are data. Select the bar graph. Chart title is request sizes. Request count is the y-axis name. Size as the x-axis name is the label. For the x-axis column we select for the y-axis we select the request count, and for the x-axis we select the size. And go to next, and as the title let me set request sizes, and for the gadget name, gadget file name, we'll enter req size. Refresh rate will be 60 seconds and generate. This is the location. This is the gadget XML location. Go back to the gadget server and add the gadget. The gadget location and the gadget. Okay, now you can see the request size variation with size. Because there are too many sizes, you won't be able to see the size. You can filter this according to your requirement, and you can get the more clearer chart, much clearer chart uh, according to your requirement. So this is just a demonstration how to create this kind of analytics from BAM. Okay. Let me wrap up the content we have discussed up to now. We have modified our HTTP log sample to monitor a custom log file which you can download from the given location, and you can use your own log file as well, and you can use Hive to split the log entries, and you can analyze them in a massively parallel way using Hadoop with the help of Hive language, and you can store the results of the summarized data in relational databases, and you can visualize those data in dashboards or gadgets, and also you can create reports on the content. So you can use BAM as a tool to examine your insight of your business, what are the services that are used, and what are the most used services, what are the best customers, who are the audience, and so on. So WSO2 BAM is a very useful tool to get insight into your web service and service monitoring and everything, including log analysis, to achieve your monitoring requirements. So thank you for watching. If you have any questions, you can ask in Stack Overflow. We are ready to answer you, and thank you.